Hello, my name is Bryan. I go to Homestead High School, and this is my final project video for my CNC milling machine. Okay, so here's how you assemble the machine. It's very easy to assemble. Most of the parts I got were in a kit, so it didn't require that much engineering to get it to work together. Most of the stuff in this machine can be made with hex keys and a 5/16 wrench for tightening the nuts. And then there's no soldering involved because it's all using terminal blocks, so it's solderless. You don't have to solder anything. The only thing you have to do is plug wires into terminal blocks and then adjust potentiometers on the board to give them the right voltage and the right amount of current. And then all these different things can be adjusted using the 5/16 wrench as to how tight or loose the V-wheels are, which are the main part that allows it to slide along the different tracks of aluminum extrusions. Now all these aluminum extrusions are the same. They're all made by the same companies, the standard. They all use the same components, and it's just a rail that has a V-wheel with a bearing inside. Then it just slides along there and back. So it's a very simple design, and it's not very hard to build or modify. In my project is what I was doing, adding modifications, making much sturdier, adding a second rail here, and all of that. And the hardest part in assembling was when they gave me washers that didn't fit into the right bolts. So I had to file down the washers to get them to work with the base kit. So I wouldn't recommend buying the parts from them. I would recommend buying some of the washers and other regular parts from other suppliers. Okay. Here's the electronic setup for the CNC machine. It's just a Arduino shield, which is a driver controller for the stepper motors. And so it has 3 driver chips, TI driver chips, and 3 potentiometers to adjust the voltage, and then 3 terminal blocks so you can connect all the stepper motor cables to it. And then it has a USB port on the Arduino Uno, which you connect to your computer to send G-code files and other data to tell the stepper motors where to go. And then you solder 3 limit switches onto the 3 pins on this side of the board, and then you solder positive and ground on this side of the board, and you connect the limit switches up so that when it hits one, when it presses down, it causes the machine to stop and cut whatever it's doing to stop itself from destroying anything in the work area. And then I also installed a limit switch here so I can press it and emergency stop the entire machine, stop everything moving, cut the power, so that it'll save anything. And if anything goes wrong, I have a backup. And then I have the fan to cool the electronics because they were originally overheating in the beginning, and they would cut out halfway through a job, and then I would lose all my progress and have to restart from the beginning. So I had to buy a fan to cool down the motor drivers. And that's it. The electronics were not the hardest part. Another difficulty in building the CNC machine was getting software that interacted with the controller well and didn't cause any errors or issues. One problem I had was that there was lots of open source versions of software, but none of them seemed to work, and they all seemed to work sort of, so I could get there almost. It would be the guys that would be working, and then it would cut out halfway or something would go wrong, or go too deep down and gut into the actual board. It just wasn't working correctly for the way it was intentioned. And then I finally found 2 open source solutions that did work, and 2 commercial solutions that do work. And then I started using those and began to use both of them in combination with each other to create a working solution and be able to pretty much mill any part I could ever need for rockets, nose cones, centering rings, fins, really anything that I could want. I could pretty much make it with the tools I have right now in open source or in commercial alternatives. So for open source I use Inkscape, which is a 2D vector and CAD editing program for drawing 2D designs. So that's easy to make fins and centering rings. And then there's also SolidCam, which is a SolidCam and SolidWorks, which I can use for 3D models such as nose cones and other 3D shapes, where I can model it in and then machine it out using that, and it'll create the G-code for it. And that's the commercial option. And then for the open source option, I use MakerCam, which is just 2D. It only does 2D images. So you create the image in Inkscape and then import it into MakerCam, and then you can set all the parameters like how thick your tool is, how many RPM your spindle is, and all of this information about the about what your tool is and your workspace and your machine, and then it'll make the G-code for you, and then you can send it to the controller, and that'll parse it, and then send the raw data to the stepper motors that'll move according to how they're supposed to. And it's an XYZ coordinate system, so there's nothing too complicated about it. Okay, so these are some of the modifications I made to the machine over the course of the BlueStamp program. I added a dual Y motor system so that I'll get more precise circles and it'll improve accuracy across the board. I bought a new spindle which can do aluminum and soft metals along with hardwoods such as cherry or oak, and then it'll give me bigger tools, so I can get up to 1/4 inch diameter tools, whereas the other Dremel tool only got me up to 1/8 inch. This new one will give me up to 1/4 inch, and then I have a new Z assembly which uses a new threaded rod, an Acme threaded rod, so it's much more precise in how far it goes up or down. And then I 3D printed a turned thumb screw essentially to move this up and down manually to zero out the machine when I put new material on. And then another modification I made was doubling the X so that I can have more support for the Z axis on the X on the gantry, so that it's double the space, so it spreads the weight out more evenly and helps with this flex that you can see on the Z axis. And so I joined two pieces together made holes for more screws, and then also joined them with 3D printing a joiner clip that's like an X that you just shove down the center of the aluminum extrusion, and then it holds it together nicely without glue or anything. And then I made belt tensioners, which work much better than the default ones, out of brass and door hinges. Thank you for watching. This is my final project video. I would say this project has been a smashing success. I've assembled the kit and got all of my modifications to work well, and the machine reliably works every time I've used it, and everything seems to be going well. I just have to do some fine-tuning and do some dialing in with some calipers or other precise measuring equipment. And thank you for watching. This is my final video.